Let the set omega is 1, 2, 3 and so on represent the collection of all possible outcomes of a random experiment with probability of an event n is alpha n for n belongs to this omega. Then which of the following statements is not true? So if we consider this omega, so omega is 1, 2, 3 and so on, and probability of this n is nothing but alpha n when n belongs to this omega. So an is greater than or equal to 0 and summation n is equals to 1 to infinity, an must be equal to 1. So that means this an is probability mass function on a countably infinite sample space. So if we consider first option, so we need to find which of the following statements is not true. So if we consider the first option, so we have like limit n tends to infinity, alpha n is tending to 0. So limit n tends to infinity an must be 0 because if summation an converges, then this an must tend to 0. So we know that summation an is 1, which is less than infinity. So that means limit n tends to infinity, an must be 0. So therefore first statement is correct. If we consider the second statement, so limit n tends to infinity, summation n is equals to 1 to infinity, square root of alpha n converges. So we can take a counter example. Suppose if I take like an or alpha n as c by n square, where n is going from 1, 2 and so on. So we know that summation 1 by n square from n is equals to 1 to infinity is nothing but pi square by 6. So that means c is nothing but 6 by pi square in order to ensure summation an is 1, where n is going from 1 to infinity. So that means if we consider summation n is equals to 1 to infinity, square root of an, so that is summation n is equals to 1 to infinity, square root of 6 by pi square n square, which is root 6 by pi summation 1 by n, where n is ranging from 1 to infinity. Now this is nothing but infinity because summation n is equals to 1 to n, summation n is equals to 1 to infinity, 1 by n is infinity. So therefore the statement B is not always correct. So option B is the correct answer.